Hello students, welcome to my YouTube channel. In this video lecture, we are going to answer the next remaining questions from Airfield chapter in Keith Williams' performance book. Let's start with question 51. Easy. What is distance A to D in the diagram? Okay, so A to D. Now AB is your runway or takeoff run available, right? BC is your stopway and BD is your clearway, right? So we have been asked to find out AB. So AB is nothing but AB plus BD. AB plus BD. So what is AB? It is takeoff run available. What is BD is clearway. So takeoff run available plus clearway equals to takeoff distance available. So option Bravo. Next. What is excuse me? What is distance B to C? So A to B again, takeoff run available, right? B to C, stopway, D to D, clearway, right? So BC is what is it? So BC is stopway. So correct answer is option alpha. Next, what is BD? So again, AB is your runway, also known as takeoff run available. BC is your stopway. BD, the entire measurement will be your clearway, right? So what is BD? It is delta. It is clearway. 54. What is the maximum length of BD in the diagram? What is BD in this diagram? BD is nothing but clearway. If you have watched my previous video lectures, you will be familiar uh, with the answer, or you will be familiar with the expectation of this question. Now BD is nothing but your clearway, and clearway will be or can be maximum 50% of takeoff run available. The measurement of clearway can be maximum 50% of takeoff run available. So what is takeoff run available in this diagram? It is A, B. It is A, B. So 50% of AB, right? So option alpha. What is the gradient of runway 27? Okay. What is the gradient of runway 27? Now here they have shown the northwards, the north datum. So this is your north, this is your east, west. So this is your east, this is your west, this is your south direction. So 0, 9, 2, 7. We have to find the gradient for runway 27. Gradient is nothing but runway slope. Whether this runway has an upslope, a downslope, what? So the formula for gradient is difference in elevation divided by takeoff run multiplied by 100. So in this diagram, so there is this runway 27 will be here. Okay, A to B. We are taking off from runway 27. We are taking off from runway 27. Now what is the elevation of Bravo? 550 feet. What is the elevation of Alpha? 500 feet. So that means when we are taking off from runway 27, this end of the runway 27 is at a higher elevation than the elevation of this end of the runway, runway 09. So runway 27 is higher than runway 09. So when you take off from runway 27, you will be flying a down slope. You will be flying along uh, a downward slope. Okay. So the slope is very small, just a difference of 50 feet. So, but still it's a downward slope. So there will be a negative sign in your final calculation. Okay. So difference in elevation, 550 minus 500, it is 50. Takeoff run available. So you're taking off from runway 27. So B से लेके A. So B to A or A to B, it is 2000, right? Into 100. So 50 into 100 divided by 2000, 2.5. So a 2.5 percentage of downward slope, right? So correct answer is delta. Next, brake release point. Brake release point means you are completely, you have entered the runway, lined up with the runway center line, you have received your takeoff clearance, you release your brakes, you add engine power, full takeoff thrust power, release brakes, okay, and your aircraft starts begin to bowl or roll along the runway. So that is, this point is called brake release points, the point, the moment when you start rolling down the runway in pursuit of takeoff. So brake release point is 1500 feet above mean sea level, meaning that particular end of the runway from where you are taking off is 1500 feet above mean sea level. Runway slope is minus 2%. So you are taking off from this runway. The slope of this runway is minus 2%, meaning when you are taking off from this end of the runway, as you start rolling down the runway, you will be rolling downwards, or you will be rolling down along a downward slope. Okay, so runway 27, let's say this is runway 27, this is runway 09. Both are not located at same elevation. Runway 27 is higher than runway 09. So as you start rolling down runway 27, you will be approaching, or you will be flying along a downward slope, a little bit downward slope. Okay, so this signifies that takeoff distance required is 3000 meter. Takeoff distance is takeoff run available plus clearway. If the elevation of the first obstacle beyond the runway, runway ke bahar, there is an obstacle which is 2000 feet above mean sea level. What is the height above reference 0? So I'll draw a simple diagram. This is your runway. Okay, and this is your mean sea level. Let's say this runway end is 1500 feet above mean sea level. There is an obstacle which is 2000 feet above mean sea level. Okay, now you have to find the height of this obstacle from this reference 0. What is reference 0? uh, uh, Reference 0 is the point on the ground. Okay, so you have to find the height of this obstacle from reference 0. So once you take off from your ground surface, you will have to cover this much height in order to overfly that obstacle. So how to find that out? Now now this is one simple diagram. Now let's modify this diagram a little bit. Your runway has a downward slope like this. Okay, has a downward slope like this. This is your brake release point over here, from where you begin your takeoff roll. This is one end of the runway, let's say runway 27. This is the other end of the runway, let's say runway 09. There is a tree obstacle somewhere here. Once you take off from here, somewhere here, like this, You have to find the height of this tree from this reference 0 ground surface. Given in the question, this is your mean sea level, elevation, elevation 1500 and 2000. Okay. In order to find the height of this tree, you will have to know uh, the elevation of reference 0. Okay, the vertical distance of this reference 0 ground surface from the mean sea level. Once you know this, you will do subtraction. 2000 minus this value will give you the height of this tree above the reference point. So how to do that? The elevation of reference 0 is the elevation of brake release point. What is the elevation of brake release point? 1500 feet plus slope. What is slope? Minus 2%. Okay, a downward slope of minus 2% into takeoff distance available. Takeoff distance required, that is 3000 meter. 3000 meter मतलब runway से starting from the runway to the end of this obstacle, to the end of the clear way where the to the end of the clear way where the obstacle starts. So 2 into 3000 meter. Now pay attention, this is 3000 meter, this is 1500 feet. Okay, so I will rewrite here 1500 feet plus slope minus 2% into takeoff distance required. Now takeoff distance required here is 3000 meter. 3000 meter equals to how many feet? 1 meter equals to 3.28 feet. So 3000 meter will be 3000 into 3.28, that is 9840 feet. 9840 feet. So what you do is minus 2%. So minus 2% is minus 0.02. 0.02 into 9840, 1500 minus 197, so 1303 feet, right? So this is 1303 and let's say 1300 feet. So what is the height of this obstacle? 2000 minus 1300, that is 700. Approximately 700, so option brown. 57. Brake release point is 1500 feet. Runway slope is plus 2%. That means you have an upslope now. Takeoff distance required 3000 meter. Elevation 2000 feet. What is the height above reference 0? So you are taking off from this runway 27, let's say. Runway 09er. As you take off from runway 27, you will be rolling down along along this runway which has an upward slope of 2%. Okay, so this is your reference 0. There is an obstacle here. Draw mean sea level, something like this. Label this. Runway 27 or brake release point is 1500. The obstacle is 2000 feet high. Okay, and we have to find this distance. To find this x distance, we must know the elevation of this reference 0 from mean sea level. What is the formula for that? Elevation of that reference 0 equals to break release point elevation plus slope into takeoff distance required. So 1500 feet, slope is 2%, so 0.02. Takeoff distance required is 3000 meter. 3000 meter equals to 3000 into 3.28, 9840 feet. So 1500 plus 197, 1697 feet. So x will be equal to 2000 minus 1697, 303 or approximately 300 feet. So anyways, option alpha. Okay. Next, if the obstacle in previous question is 1000 meter from the end of the takeoff distance required, what is the gradient of a flight path that will just touch its top? Gradient means we have to find the climb gradient or the climb uh, gradient required, the slope required. So the formula is climb gradient is equal to height change divided by distance into 100%. So height change, we have to make a height change of 303 feet. 303 feet. So 303 feet. Horizontal distance. Now this obstacle is given in the question. This obstacle is 1000 meter from the end of the runway. 1000 meter from the end of this clearway. ठीक है या फिर रनवे ऐसे समझ लो. So 1000 meter somewhat like this. Now 1000 meter is nothing but how many feet? So 1000 into 3.28, that is 3280 feet. 303 divided by 3280 multiplied by 100, so you have an answer of 9%. So C, okay, plus 9%. If the obstacle in question 56, okay, is 10,000 meter from the end, what is the gradient? So 56. Now in question 56, over here, the height of this obstacle was 700 feet, right? So pay attention to the value. 700 feet. So gradient equals to height change divided by horizontal distance 10,000 meter. So 10,000 into 3.28, that is 32,800 feet into 100. So that is 2.1%. So option bravo. Screen height. Yeah, next question related to that. For an unbanked class A aircraft, straight and level, the screen is assumed to be at dash height and located at dash position. So screen height. screen height is this, 35 feet above the runway. Once you lift off and you are 35 feet above the runway, that is called screen height. It's different depending on the type of aircraft. Okay, screen height is dependent on type of aircraft, ambient atmospheric conditions. So 50 feet, 35 feet, wet runway 15 feet. Okay, so remember it's 35 feet generally, just like glide slope, 3 degrees is the standard. So for screen height, it is 35 feet and it is located at the end of takeoff, distance required at the end of takeoff, run available. So it is at the end of takeoff, distance required. Fine. So 60 is Charlie. So this brings us to an end of this successful lecture. I hope you have understood all the 10 questions I have answered and explained. Practice these questions again and again. It's very important. The performance, all these questions are performance based. So when you actually start your flying, whether it's Cessna or an airline, this performance concepts understanding will strengthen your understanding of atmosphere, how your aircraft behaves in atmosphere, the factors that influence its performance, right? So all the best, and I request you all to subscribe to this channel, share this video lecture with your friends who are preparing for exams, and if you have liked this lecture, enjoyed it, hit the like button. Thank you.